In this video, we will quickly see some of the important concepts for rational functions. So rational functions are of this form. It's a polynomial over another polynomial function with the denominator not being equal to 0. So in a rational function, the domain becomes important. So I'm going to take just one function right now to describe to you some of the important features. So let's say I have a rational function of this form. So this rational function is not in its simplest form. It's not factored yet. So the first thing that we will do to this rational function is just simply factor the numerator and factor the denominator. So then we write the domain of this rational function. When writing the domain of the rational function, just focus on the denominator because your only concern is that you avoid division by 0. So there are two factors in the denominator. So this is the first factor, this is the second factor. Now when you set them each separately equal to 0, the two x values that must be excluded are 0 and -1, right? So these are the two exclusions in your domain. Then you look, is there any common factor between the numerator and denominator? Okay. If so, cancel. So in the next step, I'm going to look for common factors between numerator and the denominator. If there is one, cancel it. So the 0 of the cancelled factor becomes a hole on the graph. And that x value does not become a vertical asymptote. All right. So in this function that I have just been working on, there is no common factor, which means there is no hole in my graph. So this is now factored and in the simplest form because there is nothing in common. So I'm going to write this down here to work on it from now onwards. So my function written in the factored form looks like this. Okay. So based on this, I can answer a few questions right away. First, what are the x-intercepts of my function? To find the x-intercepts, you have to find the zeros of the numerator factors. Okay. So in this case, there are two factors in the numerator. The first factor yields x equals 2. The second one gives me x equals -2. So that means I have two x-intercepts at 2 and -2. What is the y-intercept of my function? To, to find the y-intercept, I have to make my x equal to 0, right? But x equal to 0 is not in the domain. Therefore, there is no y-intercept. Okay. So the domain restrictions, if you recall, we said that the domain is such that all values of x not equal to 0 are -1. That's what we said. And since we did not have any factors common to cancel between the numerator and denominator, each of these domain restrictions becomes an asymptote. Okay, so I have two vertical asymptotes at x equals 0 and x equals -1. Then, to find the horizontal asymptote, I ask the following questions. Is the degree of numerator less than degree of denominator? Look at this. The degree of the numerator was 2. The denominator also had the degree 2, correct? So the degree of the numerator is not less than the degree of the denominator. So I answer no to this question. If I had answered yes to this question, my horizontal asymptote would have been y equals 0. The second question is degree of numerator equal to degree of denominator? The answer to this question for me is yes. So which means my horizontal asymptote is given by the equation y equals leading coefficient of the numerator over leading coefficient of the denominator. So what is the leading coefficient of the numerator? If you look at this, 1 is the leading coefficient of the numerator. 2 is the leading coefficient of the denominator. So my horizontal asymptote is at y equals 1/2 is my horizontal asymptote. Now, if you answered no to both of these questions, there is no horizontal asymptote. Okay? Okay, so now based on all of this that we have, let's see how our graph is going to look like. So I do have an asymptote at x equals -1. So label it like this. I have another asymptote at x equals 0. Label that like that. I have a horizontal asymptote at y equals 1/2. I have an x-intercept at, what was it, -2 and +2, right? So -2 is probably somewhere here. +2 is somewhere here. Okay, so this is all I have so far. Okay, so now I have to graph this, right? So based on this, I can graph it, but let me walk you through it with more details that you could have, okay? So when you're trying to graph this, you have to look at the multiplicity of the zeros that gave you the vertical asymptotes. So if you look at your denominator, each of these factors has a power of 1. Like the x is raised to the power of 1, x plus 1 is raised to the power of 1. That means at both of these vertical asymptotes, right, if I were to just graph them like this over here, just to illustrate to you, so this is what I will be looking at. So my graph can either, suppose say, my graph is going to positive infinity from here. It has to be going to negative infinity here, right? So this behavior has to be opposite. And the same thing has to happen to the other, right? So if this is going up here, this has to come down here. I could have had the opposite behavior as well, meaning it was coming down here and down here, up here and up here. So both of these are possible. Now, which one of these two is going to work out for me? For that, I look at my points. because of those two x-intercepts, I already know that this portion of the graph, like this portion and this portion, are below the x-axis, correct? Because of the point. The two ends of my graph have to be either. So if you look at the horizontal asymptote, my graph has to go, this is the end behavior. It has to go like this or it has to go like this. Obviously, the graph is not going to be able to go like this because the x-intercept was here. So how can the graph go like that, right? So based on that, I already know how to graph, right? So how is my graph going to look like? I know that already, but I will give you some more indicators because it will help you when you have a different type of question on the exam. So always it is a good idea to find the sign of the function in each of the intervals. So what intervals are we looking at? So let's say this is our number line. This is the x-axis, right? So the numbers that I'm interested in are the intercepts and the asymptotes, all the x values that are of importance, okay? Now I take a test point, right? Meaning I take any x value in these intervals. I don't care, something, right? Okay. And for these test values, I have to just come up with the sign of my function. I really don't want to evaluate it. I just want to make sure that my signs are correct. If you evaluate the point, well and good for you because you can actually plot it and you can have a little bit more accurate graph. Okay. But I'm just looking for a rough sketch. So I'm just going to go for the sign of the function. So -3. So suppose say I put -3 into this, right? So what happens? -3 minus 2 is a negative. -3 plus 2 is also a negative. -3 is a negative. -3 plus 1 is also a negative. And all of these negatives together will give you a, did I do this correctly? Yes. Okay. So if you look at all of this, this becomes a positive, right? All the negatives cancel out and become a positive. This is the first number that we picked. So for this first number, our overall sign of the function is positive. Then you repeat the same exercise for all of them. So just to make it easier, instead of going up and down, I'm just going to write the function over here so it is easier for me to evaluate it. Okay, next I plug in -1.5. -1.5 will make the first factor negative, second factor positive, negative, negative. So overall, this is a negative. Then I put -1/2. So if I put -1/2, what happens? Negative, positive, negative, positive. So overall, this becomes a positive. Then I put 1 in it, 1 in the place of x. 1 minus 2, negative. 1 plus 2, positive. 1, positive. 1 plus 1, positive. So overall, a negative. Because negative times a positive is a negative, positive times a positive is a positive, negative over a positive is a negative. Next, I am going to plug in 3. 3 minus 2, positive. 3 plus 2, positive. 3, positive. 3 plus 1, positive. So they're all positive. So this is what I have. So between -2 and infinity, negative infinity, that is in this first interval, between -infinity to -2, right? The graph is positive. But remember, the graph has to be here, right? Because the end behavior is going to bound that graph towards y value of -2. So it cannot be above, it has to be below, it has to be contained there. Because your graph is going from this intercept, it is going like this, it cannot cross over the horizontal asymptote at the end. So your graph has to be over here, like so. Okay. In the second interval, -2 to -1, it's negative. So here the graph is below. So that means the graph is going to come down and go towards this asymptote. Okay. In the next interval, it is positive. So the graph is here. So that means it is starting from over here because it has to be above the x-axis. Then it goes to negative. Where does it go to negative? It goes to negative in the interval 0 to 2. So 0 to 2 is here, right? So here the graph is negative, correct? But remember, the graph cannot cross this asymptote. It cannot. So what does the graph do? The graph does an about turn and goes back like this because it cannot cross the wall of the asymptote. But in the second, the 0 to 2 interval, the graph is below the x-axis, so it is like this. Then it is going to go towards this intercept, and you can imagine what is going to happen next. So the graph is over here, just like the other side, and the graph is going to go and reach towards the horizontal asymptote from this side. Okay, so that is how the graph of the function is going to look like. So now this sign chart is very important to answer a few questions as well. So suppose say the question was, if the question was just this, right? It was x minus 2 times x plus 2 over 2x times x plus 1. Where is this greater than or equal to 0 was the question, right? So it's very easy to answer this question from the sign chart. Greater than or equal to 0 means it is either 0 or positive. So you can include all the x-intercepts as well as wherever the sign is positive, correct? So which means the interval that I'm looking at is, let me write the intervals down first. So if you look at this, it is positive here. That means I want this interval. It is positive here. That means I want this interval. It is positive here. That means I want this interval, correct? So what will my answer look like? It will look like negative infinity, -2. For the time being, I'm not going to put a bracket or parentheses. We are going to evaluate it, okay? So then I have -1, 0, and then I have 2, infinity, correct? So now my question is, am I going to put a bracket? On which ones will I put a bracket? So you have to be careful. Don't put a bracket on a vertical asymptote. You can only put a bracket on the x-intercept if your inequality had an equal to sign. Otherwise, it's parentheses all across the board. But here, my -2 is a intercept. So there goes a bracket. -1 is an asymptote, so parentheses. 0 is an asymptote, parentheses. 2 is an intercept, bracket. So this is the answer to this inequality question. Okay. Now, if the question was, where is this function less than 0, for example, then here I'm looking at wherever it was negative, right? So what are the corresponding intervals I'm looking at? These two, right? So which is -2, -1, union 0, 2. So here, because there was no equal to in my inequality, I don't have to worry about bracket at all. It's going to be just parentheses. Okay. So that is how you will graph a rational function. Let us look at one more. Let's look at this function, okay? The first thing, as I told you, is you're going to rewrite it in the factored form first. Once you write it in the factored form, write the domain. The domain is all values of x such that x is not equal to 0 or 3. Then see if there is any factor that you can cancel. Yes, there is. The x minus 3 can go away. So what does this leave you with? It just leaves you with 1 over x as your graph. Okay. So where is the vertical asymptote? It is at x equals 0 because that's what is remaining factor in the denominator. Where is your horizontal asymptote? Because this degree is 0 and this degree is 1, degree of the numerator is less than the degree of the denominator. So horizontal asymptote is at y equals 0. There is only a number in the numerator. There is no factor with x. Therefore, x-intercept is none. What about the y-intercept? Also none, because x equals 0 is not in the domain. Otherwise, you will plug in and find out. Okay. Right? So then you know how the graph of this looks like, of course. So this is all good. The only point I wanted to illustrate is that when you have an x value of 3, right, if you evaluate 1 over 3, so 3, 1 over 3 is a hole on your graph. Okay. And then you will use dashed lines to show your asymptotes like so. Label them, and that's your graph. Okay, now let's see where we might have an oblique asymptote. Oblique asymptotes happen when you have the degree of the numerator is exactly one more than the degree of the denominator, like in this case. So, how does the oblique asymptote look like? So you do long division. So x times x is x squared. That's what you need. And then you distribute. So you end up with x squared minus 3x. Subtract. This and this cancels away. This negative will become a positive. So when you add them up, negative x minus 5. So then x times negative 1 gives you negative x. So then distribute again, like so. So then you will end up with negative x plus 3. Subtract. It goes away. Negative 5 minus 3 is negative 8. So the same function rewritten will look like this. X minus 1 is your quotient, minus 8 is your remainder, over x minus 3 is your divisor. This is the remainder, this is the divisor. So this y equals x minus 1, the quotient is the oblique asymptote. Okay, so the quotient that you get becomes the oblique asymptote. All that it says is that your end behavior of the function is going to take the form of y equals x minus 1. That's it. So if you want to see how the graph of this might look like, for example, so y equals x minus 1 graph, if you know what it is, which you should, the graph is going to look like this, right? So negative 1, 1 is the slope. So your graph, this is the asymptote. Okay, so what else do we know about this? If you factor the numerator, so I didn't do all of that because I was just going to illustrate the asymptote, but let's just do that anyway. So you have x minus 5, x plus 1 is the factor of the numerator, which means that you have 5 and negative 1 as the intercepts. So there is an intercept here, 5. There is an intercept here, negative 1. Then what is the y-intercept of this? So y-intercept will be 0 minus 5 times 0 plus 1 all over 0 minus 3. So that is negative 5 times 1 over negative 3, which is 5/3. So 5/3 is the y-intercept. So where is the y-intercept? 5/3 is 1 and 2/3, isn't it? So that is somewhere here. So this is my y-intercept. So I need a graph, and let me also draw the vertical asymptote. The vertical asymptote is at x equals 3, right? So that is somewhere here. Where is my oblique? I have already drawn. Okay, so the oblique is there, the x-intercepts are here, y-intercepts are here. Now we need a graph that is going to show this behavior. So at the end, it is going to try to approach this line, right? Then it is going to pass through these points bounded by the asymptote here. Okay, and then in this portion again, it has to reach this line, but it has to pass through this as a intercept, right? So together, putting it together, this is how your graph will look like. So just to make the point that at the two ends of your graph, it is going to approach your asymptote. Okay. And then finally, when you're trying to rewrite the equation of a function given um, a graph, then just work backwards. Make sure that your numerator incorporates all the x-intercepts and the denominator incorporates all the vertical asymptotes, and keep in mind the degrees given to you, so that the horizontal asymptote, the degrees have to be either numerator less than the denominator, or they're both equal, and all of these characteristics of a rational function to look at what is the graph given to you to write your function. Okay, maybe I'll find an example. So let's say a graph like this is given to you and the question is asking you, can you write a possible function for this graph? So this is how I would start. Let me look at, so let me come up with a rough idea and then we can fix it, all right? So I know that there is an x-intercept of negative 4. So immediately I put x plus 4 as a factor in the numerator. So another one was 1/2. That means x minus half is a factor, okay? Where are my asymptotes? My asymptotes are at negative 2 and 1. That means x plus 2, x minus 1, okay? So this is what I have, right? So I'm going to write this as like so. So I'm just putting it as 2x minus 1 because that gives you an intercept of 1/2, okay? So this is my rough idea. Then I had to check out whether the horizontal asymptote works out or not. So how do I check that? Okay, my horizontal asymptote was y equals 2. That tells me immediately that the leading term of the numerator and the denominator should be, this has to be 2 times whatever x to the power of something. These two powers have to match, right? So basically this box and this box have to match, but the leading coefficient of the numerator is twice more than the leading coefficient of the denominator. So now let's see, what is my leading term of the numerator? It's 2x squared. What is the leading term of the denominator? It is x squared. So it matches. So I don't have to do some workaround to get what is the value of this number a. Like, what is a? Here a happens to be 1 because everything checks out. So my answer is this function is nothing but x plus 4 times 2x minus 1 all over x plus 2 times x minus 1. Now, suppose the horizontal asymptote number exactly doesn't match, you will have to adjust this number so that it matches with your horizontal asymptote. Okay, so some adjustments might be necessary. You might have to multiply it by some number, divide it by some number, whatever it is. Like, you'll have to make some adjustments. All right.